Good morning, everybody. In our next webinar, there was quite a time before the last one, but COVID quarantine things happened. And today, I would like to show you some, I would say, basic framework for making the model with logistic loops. And so I will tell a little bit how to build it, what are the good practice, how can you model the initial stock, how can you model the usage of the parts, and of course, how can you model the calling, I think is the most important thing. How can you call for the transport? How would you like to start the loop? If you want to start this loop as a time-based loop, or maybe some event-based loop, or maybe you want to start a loop when some product quantity drops below a certain level. Okay, so let's start. So as before, I will try to show you. Again, this is like basic framework. It can be, of course, built in more advanced way if you want, but this is the basics. So this is all the good practices that needs to be in the model to help you then build this into more advanced, bigger simulation. Okay. So first we will start, for example, with some parts. So we have some buffer. I'll maybe name it like B1. There's some processor and sync. And this is, let's say, this is our production line. So we have buffer from one part, we have processor, you will be using those parts, and we have the sync. And what you have to do first in this situation is you have to have some initial stock. Okay. So I will create a table, global table, name it initial stock. And I will create some initial stock on the B1 buffer. So in this table, let's say I will have two columns. This is like the buffer. This is going to be quantity. So the buffer, I will use it as a string, and I will just write B1. The name has to match here. I write quantity, let's say 5. I want to start the model with five product on this B1 buffer. Okay. So now let's go to the process flow. What we want to build here is we want to have logic that we create in this buffer this amount of parts. Okay. So we create the event trigger source. I want to create as many tokens as I have rows in this table. And I will create the label, let's call it stock row with the token index value. So this lets me enumerate tokens. So first token we have value stock row 1, second 2, third 3, and so on and so on. And then I would like to create some parts, to create object. I will create, let it be box, quantity. I can use global table lookup from initial stock table with our stock row, first row, second column. And I want to create this using this object by global table lookup. So from the initial stock, again, stock row, but here the first column, because in the first column, I have the name of the product. Here I have second column, because in the second column, I have the quantity. So with this logic, when I resend run, it automatically create 5 flow items on this B1 buffer, and I will start production. If you want to add more lines, more buffers, you can just copy those. Let's say I will name it B2. I can add one more row in a table, call it B2, and quantity, let's say 8. This will let me create 8 pieces on this buffer. So after this, it's relatively easy for you to just add more buffers on your line and to create initial stock for each of these buffers. You can also, of course, add more information. Like, for example, I will add one more column, let's say pieces per box. And I write here that this is like 25, and this is like 30. Yeah? So I can provide more information from my model using this insert stock table. So then I can create one more table, one more label on a created product. I will call it quantity. And here, table, global table lookup, initial stock, stock row, third column. So now I will create reset run boxes, and I have the quantity information on each box. Yeah, so this lets you easy add more information about what is on the buffers and what are the information there about this product on this buffer. So this is like the base. You have, let's say you have some production line. Okay, now you have to create some loop. So with network node, let's say we build something like this, some base loop. We get some task executor. Let's start in this location. We have to go this way to reach these buffers. So we created a one-way connection. Right click on the arrow, no connection. Non-passing option means that if you have multiple transport objects, task executors on the network, they can't pass each other. So mean that, for example, you have like slower forklift and faster AGV or something, or the other way around, they can't pass each other. Okay? And let's create some queue here, or name it warehouse. Okay, so we want to create some looping. So we want to make this AGV go in this direction and bring some product here. So with the logistic loop, usually you have two possibilities. Yeah, maybe we create both. First possibility is that we are making a loop with some time interval. And so, for example, in our model, I will start with inter-interval sol. It's going to be loop time interval. And let's say I want to make this loop every 5 minutes. Yeah, so I will just write here 300 seconds. So every 300 seconds, a token will appear, and I want to start a loop. This checkbox arrive by time 0. If you check this, meaning that the first token will arrive at 0 time, and then the second token will arrive at 300-second time mark. If you uncheck this, meaning that the first token will arrive at 300-second mark. Okay? So depending if you want to start the model with the first loop or do you want to wait, this is the checkbox that you need to think about to check or uncheck depending on your need. If you have initial stock, like I did here, usually you don't need to make this first loop. Okay. Okay, so let's build up. So we have some resource. Let's go to transporter 1, for example, make the reference. So every time we do some acquire, transporter, and let's start the loop. So for example, we make him do some travel, warehouse, then I will make him take some parts. So maybe I'll make some, let's say there's an operator, yeah? And I want this operator to load this transporter. Let it be some kind of AGV. So we'll do some run subflow, start and finish. We're going to load transport. Let's say I will load three boxes, or maybe I have five boxes. Yeah. Okay, so I will create another resource here. I have transporter I have some warehouse operator, this guy. Let's call him operator. And I want to load the transport. Okay, so I can have some racks, of course, something like this, but for the sake of this example, I will just make the product appear from nowhere. Yeah? So I will just make this operator token operate. I will make him go to the warehouse. Yeah, I will create the part in his hand. So I create it in the operator. Something like I already have it. Assign it to item. And then I will make him travel to our transporter. And then I will make him unload our operator or unload item on a transport. And I will make him do this run one tokens one at a time, meaning that he will do this one at a time. If I uncheck this, then 5 tokens is going to be created at the same time here, and the logic won't work. Okay? So let's see how it works. Reset run. We have to wait for 300-second mark. Transporter is coming to the, let's say, load location. Error in travel. It's operator and transport. If you ever have an issue in the process flow, like I did before, is loaded. I've made the typo here, yeah? So I leave here destination. So when you run the simulation, recent run, yeah, we get the error message. But you have an error. It's connected to operator number 1. So this is the guy. Task number 1, travel. So there's something wrong with the travel operation on the operator number 1. And when you click OK, the module will automatically stop, and the token will also be stopped when the error is. So you can see that I have a problem. It's going to operator number 1. I can use, for example, this to see when where this token is. Okay. So this is the error in this here, and I can see, oh, I didn't put the transporter in destination. So FlexSim kind of helps you find out where the error is. So if you reset run, the transporter is now loaded. What would be the difference if I put this acquire release inside here and this? This is a small thing, but it can be important. If I put like if you put this like this, so the run start is between acquire and release. This means that this operator has to finish loading this transport before he can start load other transport. But if I put it like this, recent run, if you have this, oh, I didn't release him. You have it like this. He will do this as a 5 separate tasks. So if the multiple AGV or multiple transport are here waiting to be loaded, this operator can break the task. So he can, for example, load this one by one. Yeah? One part on this transport, one on this, one on this. Yeah? So it will impact how the operator is handling multiple transport at once. So this means that okay, you have separate tasks. Each task is separate. Each taking and loading one part is a separate task in this situation. Yeah? So first you can see it goes 5 times. It's a separate task. So the operator can load multiple transport or multiple AGVs at the same time. So this is the difference. It's a small difference, but it can matter if you have bigger models. If you load the transport, then of course you can use some travel. On our transporter, let's say tag it to the B1, and then we'll have another run subflow. When we have unload transport, and we'll use the start and finish again. And now the question is, how do you want to do this? And do you want to have operator who unloads? Then we'll do it like we did before with travel load, travel unload. Or in this case, for example, I would just use the move object logic. Quantity of unloading is going to be token dot transporter dot subnode length. So as many as transporter has, unload that much. And I will move transporter last to destination. Destination is going to be our B1. If I now reset and run it, 300, transport is going to be loaded. Not the trouble from network. Let's connect the network nodes. And he will leave 5 parts here. Okay, this is like the easiest way. Yeah? This is the first possibility. Yeah? You have a loop time interval. The other possibility is that you want to call the transport if the content on this buffer will drop below a certain level. Yeah? So let's copy this, for example, with a very similar logic. But instead of this loop time interval, I'm going to do like this with the source and with the wait for event. So in this block, I'll wait for events. I'll wait for the something that happens in my model. In this case, I want to wait for the content change on this buffer when it will decrease to exact value, for example, 5 or maybe 4. Okay, so I will call for the transport when there will be 4 pieces left on this buffer. And the rest, I say, will be, let's say, the same. I'll just make one change, go to B2, and here B2. And here at the end, I will release our transporter, and I will look back again, wait for this event. Here also I have to release the transporter. So very similar logic. The only difference is how I fire this logic. So this is a loop time interval. So after some time, do something. And here is wait for event. If I reset and run it, when this will be 4, 5, you can see it's 4. I call for transport, loading it. And unload. Maybe I will also add after each route, each loop, transport to go back and go back to the warehouse. Yeah? I don't want the transporter to stay in this location. Reset run. When there's 4, it goes start unloads, start loading, go in the loop, and unloads here. But maybe let's add some time also, let's say 5 seconds in this move, so you can see it better. It goes loading and unloads all the content in a B2 buffer. Okay, why I didn't use this logic? Because I could also make here event triggered source instead of this wait for event, and I can create a token here every time when it decreased to value 4. Then I wouldn't need to make a loop and things like this, yeah, because every time we drop to 4, I will create a token. This could be risky, yeah, because this is like simple rule, yeah. If the content decrease from 5 to 4, create tokens. And why this is risky? It can happen, especially, for example, when you have operators working here or things like this, and you have this situation. Maybe I'll try to show you. Okay, 4 came, yeah, is a 5, 4. Yeah, you've called for a transport, so the token will appear here. The transport will came, he will start unloading. For example, let's say you have only 3 left. He starts unloading, so he unloads the first, he unloads the second, it's 5. And in this exact moment, the machine took 1 piece, so then the token will be created here. And you have like the extra call for transport, because it can happen that this rule has been met because the content change, it decreases from 5 to 4. Okay? But you were in the middle of transport, you still have something to load on this buffer. Okay? And this is like more safe option, just better option, because it tells you, okay, when I have to start to wait for something. And you also have some more options, because you can fire if initial value meets the rule. Because, for example, if you came back here, check it, and it's already below this value, below this level, the transport is going to be called again. In this way, no. You can also make it like you can have like both logic, because here you have loop time interval, and you can call for transport when the content change when content drops to 4, and you can also call for transport with the use max wait timer. So, for example, I write here just like only, let's say, 10 seconds, because I want you to see it. So wait for the value to drop to 4, or wait some time. So it can be time loop interval unless the parts level drops below a certain value. Yeah? So we will release token to the first destination. So connector 1, meaning here. So now if I and run it, you will see after 10 seconds, the transport will be called automatically. Okay? If there isn't this here enough, there isn't the number of parts didn't drop below 5, but I still call for transport because the time rule has been met. Okay? So with wait for event, you have multiple options here. And so you can call the transport when certain part level drops to something, you can call it by time. You can also add more triggers to it. Maybe I will just show you. So let's say you will have here. Let's say you have one more buffer. Let it be B3, in this B3 buffer here. Let's say quantity is going to be also 6. pieces per box 20. Okay. So we have extra buffer here. And you can add one more event. So you can, with this plus, you can call for transport if the count on B2 drops to 4, or the content on B3 drops to, for example, let's say 5. So 5, no, yes, 5 rather fast. So I have two possible events. And if any of this event happens, I will call for transport. Yeah? So for example, I will take 8 pieces now. I will take 8 pieces now. And I will maybe take 4 to B2 and the other 4 to B3. I have this set manually. So I will create one more label here. Let's call it destination. And this is for B2. And here, one more label, destination, and this is going to be B3. Thanks to this destination label, I can call it here. Oh, I have made a typo in both places. Destination. So here, I can use it now. So I can only have one logic, one subflow with one variable called destination. When I'm pointing to the object I want to unload, and with here with quantities, where do you want to unload? If you reset and run it, I will take now 8 pieces. And I will leave 4 here. And 4 here. And now, again, because the cycle time are quite fast in this case, I'll do the next loop. So you can see with this wait for event, you have a lot of possibilities. How do you want to call for the transport? And it's rather easy to just add more here, yeah? Add more events, or just add the time if you want to have like the different two different logic for starting the transportation. Okay, so those are the bases. Of course, you would like to have like the more information to it. You have to have more in the table. You have more buffers. Yeah. So for example, maybe I will just quickly add some more buffers. Big buff. Let's add 3 more buffers. If you want to quickly enumerate objects, then select them all, click here, and as I want to start the naming from 4, set object names, and automatically rename the object for you, with appending numbers with the order of creation. So the order depends where the object is inside area, where the object is on the tree. So you have B4, B5, B6. Okay, so we have 3 more buffers. Eh? And for example, you want to use the global table here to make a, let's say, transport. Good. There is a lot of possibility here. This table can look totally different. You have different information. There's a lot of possibility here, I would say. In transport, let's say you want to put the numbers of products you want to take in a table. Okay, so let's say I will have 3 rows, for example, maybe 2 columns. And here I'll use something different. I will use pointer data. So it's going to be B4, B5, B6. What is the difference between this and this? This is just a string. So this has to match the object inside the FlexSim if you want to use it. You don't have to sample it, but it has to match. If you sample something using the pointer data type, if I sample something, I create the link. If I change the name here, it also be changed here. Yeah, so let's say I will always be right. But of course, the changing the name of the object after some time inside the model is never a good way, but you have a little more redundancy here. Okay, so this is going to be our buffer, and this is going to be our quantity. And I want to take 4, 5, 6, for example. Okay, so maybe I will make it as a again as a time-based loop with the arrival at time 0, meaning I will start the model with this loop. That's why I didn't add those buffers in our initial stock. So I want to start the model with this loop. So this beginning the same loop interval, but with the at time 0, acquire, travel, go to the warehouse. I should be there, but if not, go there, acquire the transport, load the transport, have some quantity. You can write some equation here. You can write some code here. You can just write something like this, that I want to have a sum of the first, of the second, and the third row. And then you can have some loops. Yeah, so in this loop, let's say I will make some labels. Let's say it's going to be stop. Maybe transport route. And I can passive parameter like root row, and it's going to be first root row. So if I have it like this, first row of my root table, I can use it in travel. So for example, I want to transporter to go, or I can sample it. So I make a table, transport route, and the row is going to be token dot root row, and the first column. So I want to make him travel to this object because I'm in the first transport route row. I will unload transport, and the number is this, but instead of this one, I put again token dot root row. If I have it only here, if I reset and run it, the car will be loaded. And if we go stop on the first stop, so before, and here in this, I also need to change. Oh, I have it here already. Destination, table transport, token route, row, and one. Reset run. No. If you build like this, of course, you have to, it has some extra activities in here, yeah? But then you can easily add the rest of the steps. I have 2 more steps here. I want to go to the second, I want to go to the third, and then I want to go back. So if I reset and run it, before B5, B6. Yeah. So now when you build like this, you have like a control from the table. Where do you want your transport to go? You can set the destination, you can set the quantity of how many pieces. You can also, if you have like more type to it, you can add more type here for each product. Yeah, so you have, yeah, and you can also have extra column like the type. Yeah, so there can be multiple type of the same, different type of, so different product on the same buffer. Yeah? You have more lines to it. So you can build this with a more perspective or more advanced model. Yeah? But this table gives you some flexibility. How do you want to model this transport? You can set the route, you can set the quantity, you can change order here, you can change the route here. Maybe I want to go to B6 and then I want to go to B5, not a problem. So now you will go to the before B6, B5. It doesn't have a lot of sense, but it can be easily changed using this table. B6, and now then go to B5. So it'll be just up to you. How do you want to do this? Okay. We have some question here on the chat. Maybe I'll try to answer it. The question is, how would you send a different type of material to a matching destination? Example, type A only to B5, type 2 to B6, etc. Thanks in advance. You have this situation, yeah, that you want to model like with some more, let's say, more logic to it. Yeah, I would do it with the list. Yeah, so for example, maybe this is working. Okay, so I will cut this, for example. I will change the logic here. I will do like this. When you want to load this, a bit like this. Okay, I load some part. I would make a list. So I'll make a list, global list, for example, item list is going to be like parts on transporter with one label type, for example. And every time something goes into this transporter on entry, I will push it to the list. The list is parts on transporter and the item. And when I will create this item, maybe I will just copy it just for this logic so it won't be changed elsewhere. I will create here like the label type with some distribution and the uniform, let's say 1 to 3. 1 to 3. Yeah, so now when I will load it, I will load I will load the 10 pieces, but different types. Okay. And then when I go to travel, I have the unload. So I have the unload here. I would change it like this. I won't use the move object in this situation. I will also put here only one token. And I will do like this. Look on my list. So we have this list here. I will do like this. Okay, look at my list. So pull from list. But pull only the product where type equals, for example, 1. Yeah, or some number on from the label and thing like this. Yeah, I pull it, but take only once. If you find this one, it's called pulled. So pull this pulled part and move it to the value from a table, the pointer. And then check again. But if you, with max wait timer, if you don't have any more ones, go to finish. Yeah? Maybe I will just change the visual here so we can see different parts. So we set color by case, by item type, yeah, palette, okay. So if I reach and run it, yeah, if I reach and run it, I have different parts here, yeah? Not random in this case. But when I stop to the B5 before, I will only take one, so it will going to be the red one, yeah, and the rest is still there. So I think the list is the most universal way to do it. Yeah. And we have another question. Could you please show the option where the box from the warehouse unloads the queue as its content? For example, there will be a 24 smaller pieces in the queue instead of one box. Okay, so maybe let's add it here, yeah? So for example, I would do like this. You can do the separator, yeah, here, or you can do like this. Instead of move object, yeah. So first I will create object, and maybe I will create here some box copy. It's going to be smaller, yeah. So let's say 0, 1, 0, 1, 0, 1. Yeah. I will call it small box, smaller box, and I will create this smaller box in this buffer. The quantity, it can be 25, write 25, or token quantity based on this label here. The piece on this piece per box depends how do you want to build this, 25. And I would destroy the pooled ones. Yeah. So if I do like this, if I run it, after delay, that's going to be 25 smaller boxes, because I've created 25 and I've destroyed the one that I bring. So I like destroy the package and I leave on the buffer only its contents. Yeah. Of course, there can be different way to do it, because you can put a separator in between. Yeah. But this is, I prefer to have everything in, I would say, one place. Yeah. So one process flow. So I don't have some logic in the model, some logic in the process flow. So that's easier for me when I have like the more control over how it's doing. Yeah. So in this case, we have logic when I put only type 1 on the B4 and I split those in the 25. Yeah. So I have a lot of product here because I bring 4 or 5 pieces there. Yeah. Of course, if you want to again do like this, I can create one more label in this unload transport. You can create the label. It's called the product type. Let's say 1. So now I can, in the pool, instead of 1, it's going to be puller dot product type. Yeah, it will still work the same, but now I can change it. It's going to be 2. 3, and prototype 2, and 3, and then release the transfer. Reset run. I've unloaded all the boxes based on this type, and I multiply it based on the quantity inside the box. Of course, again, you can have much more options here. Yeah? You can use this label. You can mix a little bit more here. Yeah? You can create, then after this buffer, create more small buffers for different separate parts. Yeah? You can change the cycle time here, yeah? Because right now you have only 10 seconds, but you can change the cycle based on production type, on the product. Yeah, there's a lot of flexibility in this logic, and as you can see, with this loop, it's not that hard. Yeah, on the basic level, it can be a little harder when you have like very sophisticated logic. Yeah. Or where you ask someone how do you do this, and he will tell you, okay, it depends, and you said, oh, it depends on what, and said many factors. Yeah? So the more it depends is in the model, the harder is the loop to build. Yeah, but this is like the basics. Yeah, so the basics here is wait for event. So do start the loop when the number of parts drops below a certain level. Start the loop by time. We also added here the unloading based on its type. We also added here, the logic for the multiplication. You can also create a list here. What do you want to load? Yeah? Because in this case, we only put here load as a summary of this, but you can create, again, as many tokens as you have rows in the table, you have quantity, you can create more columns, you can put a type here, yeah? You can put type here, you can create a lot of different logic inside this step. Because usually, for example, you want to add something like this, yeah? And I'll maybe copy it. So this is going to be also B4, this B5, and this B6, and you can write, okay, I want to bring to the buffer number 4 four boxes of type 1 and 5 boxes of type, I don't know, 45, for example. Yeah. So you can add more information in the following columns of the table to have more details in the model. Yeah? And then, of course, you have to also make them in the process flow. And with the create object, you have to set the type not to be a random value from the uniform distribution, but to be the value from the table, from the row you are currently using. Okay. So this is the basics. Yeah. Of course, you can also add operators here in the same way we did it before. Yeah. So you have operator here, and you want him to again unload the cart, unload the wagon, and things like this. You have the pull from list here, and instead of the create object, you can just make a travel unload thing like this. Instead of this create move, you have the guy. You acquire him, make a travel, and then travel back, etc. Okay, I think that this more or less gives you the basics how this can be done. Do you guys have any more questions? So AGV, yeah, there is the library, AGV library with paths and so on, yeah. And this is the more specialized library when you want to build the logic for the AGVs. It's more specialized because you have much more control about on the movement of the AGVs inside this loop. So you can create a control point. You can create a logic for going into reverse and so going backwards with the cards and etc. So it gives you much more possibility to control the movement of the AGV. Yeah, it's a little more complicated. If you look online, I think the FlexSim US put a tutorial. I think it's 3 hours or something only about this AGV, so it can be easy access on the YouTube. So I maybe won't be covering this that much, but I would say what's the difference? Yeah, with network nodes, it's faster, it's simpler, but you have less control over movement. With this, it's a little more complicated, but you have more control over the movement of the AGV. So it will depend. Where is your problem? If the problem is with only the times and the logic for the loop, use the network node. But if you think the problem can be some bottlenecking on the road, on some crossroad, some collision on the AGV, then it'd be better to use the AGV network here. One more question. Okay, is it possible if you have a wait for event to wait only on one of the buffers, drop below quantity to assign destination on this buffer? Yeah, because this logic here, it doesn't wait for both, it waits for either of them. Okay, so it waits for either of them. So if this will happen or this will happen, you will start the loop. And if you want to find out which buffer called for a transport, you can use this logic. Assign event object to. So for example, if you assign this event or token.buffer, in this label later in the logic, you will have the information which buffer called for transport first. And because, okay, you will fill both of them on this loop, but you will know which buffer called for this transport in this situation. If you want to have, like, if you need to wait for multiple, so you want to only call for the transport, if the multiple buffers drops below a certain level, you'll have to then use the split, okay? So we split, and after split, you will put like multiple wait for events. Because like a lot of things need to happen before I will send the transport, and then in the end, the join, yeah? Oh, sorry, not the split again, but the join, yeah? So then this is the structure when you want everything needs to happen. So this needs to happen, this needs to happen, and this needs to happen before I will send out for transport. Yeah? So this is like the different logic when you want to have multiple events, when you want to check for multiple events happening simultaneously to call for the transport. Okay. So I don't see any more question. Okay, so I think thank you guys very much for this webinar. I hope we will meet soon. And I think this is something that you will asking about after our previous webinar. So ask us again, what do you want to see next? And we'll be happy to provide next webinar with something that you need. Yeah, because I remember this was this topic was especially I think mentioned 5 or 4 times by you. So this is why we did this. And we wait for your next propositions. What do you want to see? So thank you very much, guys, and see you, I hope, next month.